Algebra 1 students, here are your notes for section 5.6 where we take a look at parallel and perpendicular lines. First, just a little terminology. Lines are parallel. You can see the symbol that I have there, the two parallel lines. If they have the same slope and a different y-intercept. The reason we include that different y-intercept is if they had the same y-intercept, it would actually be the same line, so it wouldn't be parallel to itself. It would just be itself. You can see the example here. You've got two lines that both have a slope of positive 3/2, and you can see that the intercepts are different. It appears the blue line is at -1 and the red line's at positive 2 based on appearances here. All right, perpendicular lines. Lines are perpendicular if their slopes have a product of -1. Remember, the word product means if you multiply them. The way we often think about this is to think of it in terms of the slopes being opposite reciprocals. And like the example you see here, the red line has a slope of positive 3/2. The blue line has a slope of -2/3. That tells us that they are in fact perpendicular, or in other words, they intersect at a right or 90-degree angle. Now I want to show you a site. This is on your notes, but there's a cool website out there. You can see it on the screen now, desmos.com/calculator. You could play around with this just a little bit. It's like a graphing calculator on your computer screen. I've already got the line y equals 2/5 x minus 1. I just wanted to show you if I put in the line y equals, and I'll type in 2, and then use the divided by symbol, and it automatically makes it a fraction. And I'm going to go 2/5, and I'll arrow ahead to put the x, make sure it doesn't end up in the denominator. And you can see right now it starts showing up. I can do +3 if I wanted to, or if I change that number at the end, it's going to shift the line up or down. But you can see those two lines are in fact parallel. They never intersect. Now if I wanted to make these lines perpendicular, I only have to change one thing. Let's go back here where I have a slope of 2/5. Let's make that slope -5/2. And now you can see that those lines intersect at a right angle. Kind of a cool little program. I use it quite a lot actually. So something you might want to consider when you need a graphing calculator if yours is not available, or if you just want to play around with different slopes. Today would be a good day to try that. All right, so here we go. Here are some of the problems we're going to look at. Are the following lines parallel, perpendicular, or neither? Now remember, for parallel, perpendicular, or neither, all that we really need to know is the slope. As long as they're not the exact same line, then all we care about is the slope. So when I look at this first equation, y equals 4/7 x minus 5, I have a slope of 4/7. Now this second equation is in point slope form, and I can see that the slope is also 4/7. There's one more thing we have to consider here. Is there a chance that these lines actually coincide? In other words, they're on top of each other. It's the same line. And the answer there is no, they're not. If you were to distribute that 4/7 times 4, that's 16/7. It's negative. You'd be subtracting 3. This is definitely not -5. So we're good to go. Those two lines are in fact parallel. Okay, on the second one, number 2, notice the first line has a slope of -1/7. I was nice enough to give these to you in slope-intercept form, so it should be fairly straightforward work for you. And the second line has a slope of -7. Now, we said that perpendicular lines are opposite reciprocals. That is not the situation that we have here. In this particular case, we would just have to say neither. But you say, wait a minute, Mr. Hale, these are reciprocals. You would be correct. They are reciprocals. However, the signs must be opposites. So if one is positive, the other has to be negative. All right, number 3, there's a little more work involved for us. So let's look at the first equation, 8y, or 4x plus 8y equals negative 11. Let me start by rewriting that equation. And I'm going to solve for y. I want this to be in slope-intercept form. I think that's going to be the best way for us to determine if we have parallel or perpendicular lines here. So I've subtracted the 4x. I'm also going to divide everything by 8. So y then equals negative 1/2 x plus 11/8. Now you can see right here we have a slope of negative 1/2. The other equation was given to us in point slope form. The slope here was positive 2. Negative 1/2 and positive 2 are opposites. The signs are different, and they're reciprocals. So these are perpendicular lines. With perpendicular lines, you don't have to worry about the y-intercepts being the same. Even if they were, the lines would still be perpendicular. All right, question 4. A line passes through the point 4, negative 7 and is parallel to the line y equals 2/3 x minus 7. Find the equation for the line in slope-intercept form. Now there's a key word here. It's already written in bold, but the word is parallel. The reason we care about that is that tells me that the slope has to be exactly the same. This line has a slope of 2/3. So what we're looking at now is we have a point, 4, negative 7, and we have a slope, 2/3. We're going to use point slope form. So y minus negative 7 is equal to 2/3 times x minus 4. Now I'd love to leave it that way, but this problem says to write it in slope-intercept. So we're going to have to do some distribution. We'll subtract 7 from each side. Now remember, 7 is the same as 21/3, so I'd end up with y equal to 2/3 x minus 29/3. There's my equation. Number 5 looks like a pretty similar question. However, there's one pretty key change, and that's the word perpendicular. So we're looking for a perpendicular line to the given line. Now this line, negative 2y equals negative 4x plus 12. I'm putting this into slope-intercept form so that I can actually find the slope of the given line. Negative 4 divided by negative 2 is positive 2. The y-intercept doesn't really matter to us, but it's minus 6. Okay, now the key to all that was to see that the slope of this line was 2. That's not, however, the slope of our perpendicular line. The perpendicular line has a slope that's the opposite reciprocal of that. So it has to be negative, and the reciprocal of 2 is 1/2. At this point, we can use our our point slope form like we're used to doing. So y plus 1 equals negative 1/2 times x plus 5. And I'm going to distribute the 1/2 and subtract the 1. I'm going to put my answer over here. So y then would equal negative 1/2 x minus 7/2. That's the line that's perpendicular to 4x minus 2y equals 12 and passes through the point negative 5, negative 1. All right, similar kind of questions. A little twist to them though. Number 6, find the equation for the line that is parallel. Okay, keep that in mind, parallel, same slope, to y equals 8. That's the trick on this one, y equals 8. Well, you guys remember that Hoyvux phrase, horizontal lines have a slope of 0, and they're always y equals equations. Okay, so if the line has a slope of 0, the parallel line also has a slope of 0. But probably more importantly than knowing the slope of the parallel line is knowing that it also has to be in the form y equals, and then it says it passes through the point 7, negative 5. Well, that's my x value, 7 is. Negative 5 is the y value. There's my equation. Pretty simple problem, as long as you know what it's asking. All right, the last one we'll look at together, find the equation of a line that is perpendicular. Again, we've switched it, perpendicular this time, to the x-axis and passes through the point 7, negative 5. Now, when you think about the x-axis, it's a horizontal line. The slope of that line, I'll go ahead and sketch it on here so you can actually see it. There's the x-axis right there. The slope of that line is 0. And again, perhaps more important than knowing the slope is knowing that it's a y equals equation. This says we're looking for the perpendicular line, however, and perpendicular to a slope of 0 is a slope that's undefined. And again, perhaps more important than knowing the slope is undefined is knowing that it has to be an x equals equation. Now you'll note we've used the same ordered pair, 7, negative 5. It's x equals 7. It's a vertical line at 7. I hope that helps you as you prepare for the in-class work on Monday. Have a spectacular weekend, and we will see you then.